Hello dear student. Today I am discussing about the magnetic effect of electric current. What is the magnetic effect of electric current? The development of magnetic field around a wire. When an electric current flows through it, then this phenomenon is called magnetic effect of electric current. What is the meaning of this? Suppose this is a wire and this current is flowing. That means current charge is flowing. So when there is a charge flowing around the wire, they are making some magnetic field, enclosing some magnetic field like this. So in this way, there is making some magnetic field. So this phenomenon was first observed by Oersted in 1820, and from this they conclude that the production of the magnetic effect or magnetic intensity when there is a current flowing in a conductor. So basically we can say that the production of the magnetic field around an wire when an electric current flows through it, then this phenomenon is called magnetic effect of electric current. So from this effect, Biot and also Laplace, these are scientists, then find a law. This law was stated in this way: the magnetic intensity delta B, or you may write dB, magnetic intensity Tb at phi due to the current I in a small element TL of the conductor is. So at first you have to find what is dB, what is P, where I have to find the magnetic field intensity, and what is current, in which direction it is flowing, and also what is a small element of conductor. So look at this picture. This is the direction of flowing current. This is the length element. The length is infinitely long or large length. This is the angle between L and R. What is R? R is the distance between midpoint of L and the point phi where you have to find out the magnetic field. So from this figure, we can say that this magnetic field is directly proportional to the current. This magnetic field is directly proportional to the length element. This magnetic field is directly proportional to the sine of the angle, and this magnetic field dB is inversely proportional to the square of this length. Then it is written there dB directly proportional to I, dB directly proportional to dl, dB directly proportional to sine of theta, and dB proportional to 1 by r square. Combining those, we find dB varies ideal sine of theta by r square. Then taking this as equation, you have to put a constant mu 0 by 4 pi. This is constant. I already find out what is k. K is equal to mu 0 by 4 pi. Where is the k is a constant. This constant is dependent on the nature of the medium and system of the unit taken. So value of the constant is mu 0 by 4 pi, where mu 0 is the magnetic permeability at vacuum, and its value is 4 pi into 10 to the power minus 7 Weber per ampere per meter, or Henry per meter, you may write. So remind is mu 0 is magnetic permeability in free space or vacuum, and its value is 4 pi into 10 to the power minus 7 Weber per ampere per meter. So what is the direction of dB? You look, this is length element and this is r. If both a dl and r lying on the plane of the paper, then db will be perpendicular to the plane of the paper like this, or you may in the upward direction maybe also, or it may be downward direction. So this is vector product. Okay, so what is the vector form of this Biot-Savart law? Vector form is dB is equal to mu 0 by 4 pi ideal cross r by r cube. Ideal cross r by r cube. And unit of magnetic field, SI unit is Tesla and CGS unit is Gauss. Okay, I will distribute in WhatsApp these papers to you, so it may not make any problem to you to understand. Magnetic field due to an infinitely long state conductor. Look at this. This is a conductor. This is infinitely long. I am taking just a small length L, and this is length element dl. From dl, this is O, that means midpoint of dl is O, I consider. From O, I have to find the magnetic field at phi. So I have to write a direction. I have to give a direction. So x is the direction between the midpoint O and phi. Then what is the angle between x and dl is theta. I is current. So from this, my expression of Biot-Savart law will be dB is equal to mu 0 by 4 pi I dl sine of theta by x square. Look at this. Here my direction is x, so this is x square. Now mu 0 by 4 pi I dl sine theta, I have to replace theta. Theta is equal to pi by 2, 90 degree minus beta. That means pi by 2 minus beta. So I put here, and all these are same. Then what is cos of beta? Look at this. Cos of beta base by hypotenuse. I consider M to P as the base. Distance is R. So cos of theta base R by x. R by x, base by hypotenuse. So taking x is equal to r by cos of beta. So all these are there. Tan of beta is tan of beta perpendicular distance by base L by r. Look at this, tan of beta L by r. Therefore L is r tan of beta. Derivating dl is equal to r sec square beta d beta. Putting this in one equation of magnetic field intensity dB. Therefore dB is equal to mu 0 by 4 pi. All these are there. After this, I am finding mu 0 by 4 pi I by r cos of beta into d beta. So I have to eliminate dB, that means beta. d beta, taking integration from minus pi by 2 to plus pi to pi by 2. Look at this. If this line is will be infinitely long, so from the point phi, this will be so much long, so your angle will be like this. This should be 90 degree, and again if you take this should be 90 degree. So if you consider this is positive, then this will be negative. So taking the integration minus pi by 2 to plus pi by 2, then beta b is equal to mu 0 by 4 pi I by r. Integrating cos of beta d beta, we find sine of beta. So taking the limit of the integration, we find mu 0 I by 2r. So this is the first part, and another part is like this: magnetic field at the center of the circular coil carrying current. So this is, I have to find at this point magnetic field. So what is there? Biot-Savart law dB is mu 0 by I, mu 0 by 4 pi I dl sine of theta by r square. Putting this ideal, look at this, this is the vector term and this is unit vector, so this is r square. If this is 90 degree, it is 90 degree, putting value, we find this. For a circular loop, total circumference 2 pi. So putting 2 pi, we find 2 pi by 2 mu 0 I by 2r is equal to dB. Or we have, if all these are there, then magnetic field at the center of the circular coil is mu 0 I by 2r Tesla. If there are n turns, so B is equal to mu 0 Ni by 2r. N is the number of turns. Now the last one, today's discussion, magnetic field due to an infinitely long current solenoid. All these are, this is a solenoid and the wire is insulated. This wire is totally insulated and around the cylinder tightly. So every turn is perpendicular to the main axis. So if we find the magnetic field at any inside of this solenoid, any point inside of the solenoid, the magnetic field inside the axis of the solenoid will be B is equal to mu 0 by 4 pi Ni, number of turns N, therefore mu 0 Ni Tesla. This is the last part today's discussion. So thank you boys.